All right, I'm going to go over GDB debugging for STM32 using the Arduino development environment. We have two boards we could actually use for this. I learned how to do this on a Blue Pill board. These are really popular, inexpensive boards. If you get this over at Amazon, it is about $6.50, or you can get two of them for $10. Okay. This has got a F103 on it, which is a ARM-M3 processor, Cortex M3. But I'm actually debugging my own custom board today. This is a board that has an F103 on it, but it's got a little bit bigger part on it. It is a 103 RET. So this has more RAM and more flash, as well as more I/O pins. So this is a custom board I'm working on for a customer. And this is what we're actually running on for this demo. We're using for debugging and for programming, we're using a stlink version 2. These are also available on Amazon for $8.60. This allows you to do software debugging over 2 pins. And I have that plugged into my board. Let me see if we can see it. It's right over here. Let me see. I'm running into this one right here. So here's my stlink version 2. Okay. If you want to start really inexpensive, you can order this on AliExpress. You can get the Blue Pill board and the stlink for $3.15. And the shipping's 80 cents, so it's roughly $4. When it comes over on China Post, it'll get to the United States first week in February. It is now December 29th. Okay, this is for our hardware setup. We're using this custom board with a STM32F103 RET. I'm using the Arduino IDE 1.810, running on Ubuntu 16.4. So you kind of all know what this is. And I'm using the Roger Clark's version of the Arduino STM. Roger Clark was one of the persons that he probably picked up after Maple Labs stopped selling these STM32 boards. So this is a version that is based on all the Maple work, and it is a really pretty active development. You know, you can see here the last commit was 2 days ago. So I've been using this version of Arduino development environment for STM for probably about 4 or 5 years. It is not the one that if you use the boards tool within the IDE to download STM for 32, that one actually comes from ST. So, but I'm using the Roger Clark one. I am using the command line tool to run the stlink on my Ubuntu machine. This is the GitHub repository. I've already cloned this and compiled it and have that running. And lastly, we're going to ultimately get to GDB GUI, which is a thing that provides a more modern, real GUI development environment for how to run a GDB. All right, let's start. Here's our blink sketch. The Blue Pill board has an LED on PC13. Same as mine, which is convenient. We have a define here of D500. If you come down here and look at we'll just blow down here and look at this a minute. This is a little bit more elaborate than normal blink sketch. We'll talk about that in just a minute. But basically, I'm turning the LED on and off, and I have a delay here of this variable D, which is a constant 500. So the LED is going to blink on and off once a second. I'm going to set up the pin for output pin. It's pretty straightforward. So let's go in and we'll go ahead and compile this. So here's the blink sketch here. It's the same as the one that's over here on my notes page. First thing, you come over here, you set your board. Now, I'm using a F103, like I said, RET, so I have my board set up for that. But if you were using a blue pill board, you'd come down here and you could find that there's actually a blue pill board somewhere down here, past all this ESP32 stuff. Here we go. Yeah, so it's down in here. So you would end up picking this C6, which is for a blue pill, but I'm on an R, which is a little bit bigger. My board has, I'm actually on the RB board, but it doesn't matter for us. Our upload link is, we're using stlink right here. So let's go ahead and compile this, and we'll go ahead and put it over on the board. Okay, so it's compiled and it's written. So the compiler for STM actually works pretty quickly. One thing we don't know, and my light's blinking on my board. All right, so if we come and look at this output here, there's not really much information here. And we need a little bit more information to actually do GDB. So you have to come over to Preferences, and you have to turn on Show Verbose Output for compilation and upload. Probably not upload, but at least for compilation. We'll show you why that is in a minute. But we'll turn them both on and we'll redo this. We'll go ahead and compile again. And what you need out of this is you need to find the GCC line. Okay, so here's where the compiler is actually running. We're actually using G++. You need to know what the path is all the way up to there. So you gotta figure out where that is. When you do an installation on your machine, it's going to end up at a different place. I'm running off a ramdisk, so my Arduino stuff runs right out of RAM. But you need to know what this path is, because in that same directory, I'll go ahead and show you what's in that directory. These are all the GCC tools for everything. And why you need to do this is the version of GDB that we're actually going to run. When you're compiling C code and you're actually debugging, you want to run the same version of GDB that is for how it was compiled. So this version of GCC, if you look over here, it's 4.8.3-2014 Q1. All right, and so all these tools, these are tools that came with the STM32 from Roger, and we need this GDB version. Now I have this currently in my path, so I can just run this right from the command line, and you can see it right there. Okay. The other thing you need to know is, where is the build directory that Arduino IDE used? So down here you can see it is stuck in temp Arduino build. So let's go in there and show you what's in that directory. Okay, so here's everything that's, when you actually hit this compile button, it creates this directory, and yours might be different. Yours may have some kind of unique number out here at the end. But it needs it. The Arduino build environment, what it actually does is takes your Blink sketch and wraps it around a C++ class, and then it compiles everything together, and it does all this in the build directory. And so if we were CD into the sketch, you can actually see here's what actually gets compiled, not the Blink sketch, not the INO file, but this actually C++ file. Okay, so you can kind of see what's going on here. But anyway, we don't need to get into that. What's important to know is you need to know where this ELF file is, the ELF file, because this is what the GDB is actually hooks up to. All right, now keep in mind that typically when you're debugging, you are compiling and executing on the same platform, but here we're actually cross-compiling, and we're going to use a GDB server, which is a software that runs on my host that connects up to this stlink, and then we're going to run GDB, the cross-compiled version for this version of GCC on my host, which connects to gdbserver, which actually runs the compiled code over on the ARM chip. All right, I don't know, it's pretty complicated, but we're going to keep going. All right, hopefully you know a little bit more about what I'm talking about. All right, so down here, so we have the path on our notes. We have the path to the GDB that we're going to use. We also have the path to the build directory. And then I've already modified my path by just doing an export of the entire path over to the GCC tools, and then another path over to GDB server. So we're going to start the GDB server right now. GDB server is actually it's actually part of this stlink. So if you were to come over here and look at this, when you actually compile this or do the install, there is an executable in there. Let me see where that is over here. I think it is, let's see where this is located on my directory structure here. Okay, so this is actually where it is. So you can see that this is the stlink, that this is the repository, and then I went ahead and built it for Linux. And here's GDB server. So we need this st-util, and we need to start it on a specific port. So we'll first start that. We'll start it on port 1234. You see it's running there, so let me get some Windows set up here. Okay. And then we are going to cd into the build directory in another window, which we already are in here. So then we're going to run this one right here. You run GDB with the ELF file. And let's get this going like this here. So right now, this version of GDB on my host called Hendrix, which is my my x86 machine, is currently connected up to this ELF file. But we need to actually connect to GDB server so I'm debugging the compiled version that's actually running on my board. So the way you do that is you do target remote :1234. We're going to hit that, and you're going to see up here in this other window that we have a GDB connect message that came through here. So we're actually connected through here. And what GDB down here is actually showing you is what line is first going to get executed. So it's an assembly line right here, and you can look at the kind of the context that source line is in by doing a list. So we're actually sitting right now on line 51. So if we want to go to the next one, you can type in next, or you can type in an N. And now we're going to go to line 52. You can kind of see it here. Okay, so let's set up a breakpoint on over here on. We want to set up a breakpoint on setup. So you can do break B for setup, and you see it went out and found it, and it found it at line 8 in my blink.ino file, which is handy. And so now we're going to just actually do a run, which is in GDB world called a continue. Okay, so now we're actually in the blink script. So if you want to see the context of that, you can type in list, and we're on line 8, so we're right here. So in setup, we set the LED to an output pin. From there, we can set a breakpoint on loop, and then we can continue until we get to loop. Now we're on loop. So you see we're on line 11. This is kind of painful. Let's. This is the way that the real men do their debugging when they just use straight GDB. All right, I'm not a real man, so let's look at an alternate way to run this. All right, we're going to kill that, and you notice when I killed that, my GDB server up here stopped. So I'm going to start it again, and then I'm going to add a command line option to GDB. It's called TUI, which I I don't know quite what that stands for, but it's a UI that runs. It's probably in curses at the command line, and it actually shows you the context source that it's in, and this makes it a little bit easier because you actually can step through your code and figure out what line you're on and see your breakpoints and stuff. So again, now we're not connected to our target yet because you kind of see up here we're still listening on port 1, 2, 3, 4. So we're going to do a target remote again. And we're back on that assembly line. Now you're like, well, wait a minute. Why isn't it sitting at my setup line? So the way the Arduino environment runs is it runs a bunch of assembly. When the compiler compiles the code, it runs a bunch of assembly to get the microprocessor ready before it actually starts main in the C verbiage. And then Arduino doesn't actually expose main to you. Main itself basically calls setup, and then it basically has a endless loop that calls the loop command for you. We can actually see that over here. So we're going to skip over this assembly, but we're going to put a breakpoint on main. So we do a breakpoint like that. And you'll see over here, the file that it actually put a breakpoint in is called STM, all the way through the entire tool directory, down to cores, maple, main.cpp. So let's run over to main, and we're going to stop on the main. So here's the actual main program that is a C++ program that is the starting point for our program. And you see that here's my setup. So when this executes, it runs the setup over here, and then here's that endless loop that basically continues to call loop. So this is the kind of the highest level at the C language level for an Arduino sketch. Okay, so that's just for your basic knowledge. So let's go ahead and put a breakpoint on loop again. We're going to do break on loop, and then we're going to run the program, and you'll see that it stopped on loop. Now, from here we can single step, and this highlighted line will step down. So this is what that TUI option does, and you can actually see there's a breakpoint right here as well. Now I can set a breakpoint somewhere else. So let's put a breakpoint on 15. So since I'm in this context, I can just do a B on 15, and it put one right here, and we can do a continue, and then it'll stop. Okay, and you'll see that I'm right here. So let's just single step through here. So we can do a next, and you'll see that I stepped over that. And now we're in the loop now, so we're going to go back up to the for loop. We're going to run this 5 times. Okay, my light is on right now. We're going to do that delay. Now let's look at some variables. So let's say we're going to print I. So I is 1, and we're also going to print this thing called count. Okay, count is 0. All right, so count, you see that it is not a local variable because it's not within the function loop. It is well, it's kind of like a global variable at the sketch level, and so we have a local variable I, and then we have a non-local variable count. All right, so let's just pull that breakpoint. I don't even know how to delete the breakpoint. Is it delete? 15. Oops, no. I don't know how to delete the breakpoints. There's a big help command in here. Let's see if we can figure this out. Breakpoints. Watch. Delete. Okay. We can do a break delete. B delete. Let's just pull them all out. Oh, breakpoint 5. Oh. Well, shows you what I know. I'm not too versed in doing this either. That's okay. Let's oh, but I do want to show you one more thing. So let's quit out of this and start over again. Oh, come on. All right, we're going to start our GDB server. We're going to debug our thing. We're going to do our target remote. We're going to put a breakpoint. Oh, let's not put a breakpoint in at all. So let's just continue. So the light will start blinking and start counting. All right, now let's say I want to stop my program executing right now. So I can just hit a Control-C. Okay, and this is where it stopped. So it stopped in this function macros. For some reason it's running macros. And so there's probably I think it's probably step out. Is that what it is? No. Is it step? SO? Help step. Oh, we can run step so many times. Well, anyway, let's put a breakpoint back in. Oh, we can't do that. Dang it. All right, so the point is you have to know what all the GDB commands are over here. And this TUI interface is a little easier to use than just a straight GDB, because it does show you the context of the upper window right here. But you still need to know all the commands. So let's go look at a more modern, even, like a lot easier way of figuring this out, where it doesn't require you to know all the GDB commands. So we're going to go and quit out of this. We need to start our thing again up here. And we are going to run this GDB GUI. Okay, now this runs in the browser, and it shows you pretty much everything that we're... it makes it a lot simpler to use GDB. So that command over here is I'm going to run from the command line because the GDB GUI is in my path, but you have to tell it which GDB to actually use. So that's why we needed to know the entire path out to here. And this GDB GUI needs to know this entire path. So we're going to run this command. I don't know why that didn't work. Let's see here. I'm going to do that. And what this is going to do is it's going to launch a browser, and it's debugging my ELF file. Okay, remember, because on the command line, we are in. Okay, it went out and automatically found the ELF file. There should be. We do need to be in the build directory over here. So anyway, let's go over here. Okay, but now remember we're not connected to our target yet, so we need to do our target remote again. And that didn't work. Okay, let's kill all this stuff. I think that this command needs to have the ELF file in it. All right, let me just fix this whole thing here. Let's just fix our notes file on the fly. This needs to be blink.ino.elf. All right, here we go. Let's try again. All right, so we got our GDB server running up there. We're connected up, and you actually can see that the main is here. This is our main, but we're not connected to target again. So we need to do that. Target, remote, 1, 2, 3, 4. And you see now it connected again, and now it's showing us this assembly. So this is pre-main, just like it was in GDB. But now up here we have some extra things over here. We have the number of threads. We have local variables, expressions, this memory, this tree, and we have a breakpoint on main. GDB GUI actually automatically sets a breakpoint on main as a convenience. You can change that over here. If you look at these settings, you can say add breakpoint to main after loading executables. So that's an option. You can turn that off. But there is a breakpoint there, so you can see that. And we could disable it right here if we want. You see that it's pink right now, but if we enable it again, it'll turn blue. So if we do a run, which is this play button up here, this is running the continue button. And we can use these commands up here, or we can also type them in down here, just like you did in straight GDB. So these are just convenience buttons up here. And this first one is start the inferior program again. Now it turns out this doesn't actually work very well on doing remote. I haven't been able to do this, so if I have to restart my program from the beginning, I just I kill everything and start everything again. This one is to continue. Here's to pause. What is this one? Step over function call. So this is the next. This is the one I was running before, which is just a regular in. What is this one? Step into the function call. That's an S. And here it is, step out. So if you're in a function and you want to step all the way out, you hit a U or an up arrow and it'll hop all the way out of the function. And then these ones here are execute one machine instruction. So this is actually going to run the assembly code one line at a time, but it's going to show you the C source code that it's actually executing. Okay. So we're on the we're currently over here on line 51. Now you can run GDB commands here like that list command. So it's actually going to show you, it's going to take you back over to the source file. What it's showing you up here is actually the source that it's actually displaying. Okay. So let's go ahead and hit the run key, because there's a breakpoint at the setup. It's actually on main. Okay. So if we want to step into setup, we're going to do this step in, and you'll see it hopped over to our setup command. So we're going to do that pin mode, and then we're going to go ahead and step all the way out. So now we're down here in the infinite loop as part of main, which is basically going to call our loop over and over again. So let's go ahead and step into that. So now we're down here in loop again. All right, so let's look at some expressions here. So we're going to hop into loop. We're going to go ahead and do a step. I'm just going to start hitting, and I'll hit the next. So there's a next, and you'll see that local variables over here now showing us I. So let's step through this whole thing and see that I actually increments. Okay, so you see it's running. My LED just turned off, and my LED is turned on again. So I is incrementing. So let's go ahead and run this for a while. So now it's running, and it's running. And we're going to go and stop. So now we're down in this delay. So let's step all the way out of this function. So now we're back up here to main. I is 3, but what is count? Now count, remember, is the kind of the global variable. So you can put that over here in your expressions, and you'll see that count is actually 1. Now what's kind of cool about this interface is that you can display these variables. This is in base 2, base 12, 14, 16, 2, 4, 6, 8, and 10. And then now look at this little fancy thing over here. I can delete this expression, or I can actually graph it. All right, so this is where we are here. So let's run this a little bit, and then we'll pause it again. And when it stops, you'll see that count is actually 2, and we're getting a graph out of there. So if we ran this a little bit more, our graph would be incrementing by 1. And so, well, you kind of get the idea. All right, so here's our graph. All right. Well, that's it for now. Let's step back out to our loop here. We can also change these variables. I think you can come down and change these variables. So like right now I is 4, and I think you can come down here and say set variable I equals 0. Shows you what I know. I 0. How about this one? Nope. Dang. I guess I'm full of beans here. Oh, let's take that. Let's. Thought I could do that. Maybe we'd do it over here. Well, whatever. Okay, there's a couple more things. Yeah, forgive me for not knowing what these commands are. Like I said, I don't know all the GDB commands. And in fact, I just got this GDB GUI running about an hour ago. But there's some other things. If you hover over a variable, it'll actually bring up a pop-up that shows you what its variable value is. That's including the local variables as well as the global variables themselves. So you don't need to actually type this expression in. And there's probably ways that you can do conditional breakpoints. So, you know, I can set a conditional breakpoint here and only stop when count is, 10 or greater than 10. That's typically a pretty common debugging scenario. So you can let your program run for a certain amount of time and not have to continually single step through there. All right, well, I hope this was pretty helpful for you. It's very convenient. The key to this whole thing is that you have to have one of these ST-links, because this is the thing that actually connects. This is the hardware that actually connects your board, whether your Blue Pill board or in my case the custom board. It connects gdbserver that's running on my host to the actual target hardware. So you actually need this thing here, and these are really rare, really inexpensive. You can buy them in the U.S. for $8, or you can get, and you can you play around with this for next to nothing. $15, and this is a pretty powerful environment once you get GDB GUI going. Okay, well, thanks for watching.